just for the sake of kind of getting started, would you be able to introduce yourself and what you do, I don't know, in your field and what's your background?
Okay, yeah, so my name is Morgan. I work for Space NG and we help spacecraft navigate when you don't have GPS. That's kind of how we got started. My background's in computer engineering, computer science, like vehicles mostly. So when I was at Cal Poly, hacked into tractors, worked on like self-driving systems for semi trucks. And then now it's like a self-driving system for a spacecraft. So you can think of it as like a Waymo for a spacecraft. You put a bunch of sensors on a spacecraft, and then it can fly itself. And you're thinking, well, don't spacecraft already fly themselves? It's like, well, they do in simple situations. You have a stable orbit or something like that. There's not a lot of stuff that could go wrong with regard to navigating. There's plenty of other things that could go wrong. But when
Hmm.
you're landing on the moon, precise navigation is extremely important. If you look at all the autonomous landers that the US has built, we built three or four of them now, and three of them have crashed. And so the Blue Ghost lander that I worked on was the only one that didn't. And part of the reason that it succeeded was this visual-based navigation. So we installed cameras on a spacecraft. It recognizes the surface of the moon and then calculates its position and attitude, which is like which direction it's pointing
Hmm.
relative to the moon. And then that feeds the control system for the thrusters to help it like stay on course as it descends. And then we also, as we're doing our final descent, we detect craters and rocks, things that might break the lander, and redirect it to a safer location.
Okay. That is super fascinating. I mean, I ended up reading on it a little bit, and I feel like the fact that like Blue Ghost did so well, I mean, you obviously had like I don't know, but part of like making sure that that happened and it went correctly and everything.
Yeah.
One of the main things that I'm kind of curious about is what really makes autonomous landing and kind of like the navigation so difficult in a space environment.
Well, let's see. So when you're navigating around Earth, you get this cool thing called GPS. So you can talk to a bunch of other satellites that already know a precise location because they've been spinning around forever. And they have
Hmm.
precise clocks and all this advanced equipment. And you just get to piggyback off that. You get to say, hey, where am I? The moon doesn't have any GPS satellites. So you don't have any other option really besides radio ranging, which is good for stable, predictable orbits. But when you're rapidly maneuvering, it doesn't work. So you need a way to know your position, like globally know your position quickly so that you can autonomously control. And that's the challenge. So how would you do that? Well, you got to use something that you know where it is. Like the moon is like something you can reference against.
Hmm.
So this is called terrestrial-based navigation. There's some work at Carnegie Mellon that does it for Earth, which is also super cool. They like can figure out key points on the geographical terrain on Earth and navigate. So that's our approach is using cameras. And cameras are cool because you get a bunch of visual information, textures. And so we're able to cross-reference that against a map of a orbiter that had previously mapped out the whole moon. And so we're basically just referencing it against this map.
Okay. That is fascinating. So last year's competition, so not the SGC 2026, but the one before that, was called Lunar Legends, and it was
Mhm.
this entire plot about like, okay, how can we do a lunar landing, making sure
Yeah,
that space cybersecurity actually like stays correct and everything. So
totally.
now hearing about an actual lunar landing and the utilization of cameras is kind of fun to be able to tie it back into last year's.
Sure.
Um, I think on the camera side of it, something that then interests me as well is just vision navigation. I feel like it's becoming, I mean, we can see that in the success of like Space and G as well, but it's like it's quickly becoming a backbone of what like the next gen's landers and like spacecrafts will probably look at. So it's
Yep.
kind of relying on that. Where do you think where do you think we'll see the biggest like innovations happening over the next 5 to 10 years when it comes to vision navigation?
Oh man. So I mean, I think one thing that from a space perspective right now is there's a big interest in Golden Dome. Right? Like this is a
Okay.
totally new way of buying spacecraft where basically the government expects you to just come up with a cool thing and then they'll buy it. And so it's kind of on private companies to invent new spacecraft capability and demonstrate it. So it's like, but the numbers on it is huge. So that, I mean, thousands of satellites, right? And a lot of it is on detection of objects, and the fact that it's critical infrastructure means it needs to be protected. So thinking of like everyone has a Ring doorbell in their house, right? But like we really need to have like Ring doorbells on all our spacecraft to know if like something, some other spacecraft, a stealthy spacecraft maybe,
Hmm.
is doing something. So that's like one big area is what you call space situational awareness, like knowing what's around you and being able to detect objects that aren't stars or like things you expect to see in space. Um, and I mean, the other thing is like automotive technology with cameras has made has created these economies of scale and like new technologies that we are able to leverage in other applications. So cars need LiDAR now, and cars need sensors
Hmm.
to detect pedestrians and all kinds of things like that. So these sensors are now being built at scale. And then if you're building something that's maybe cutting edge or new, you now have access to all of this innovation that's getting driven by the automotive industry. So from like a supply or technology perspective, you were seeing cool stuff like SPAD sensors. So it's like
Hmm.
basically like a fixed, like it's no moving parts, but it can measure the time of each photon as it bounces off an object. So it's basically like LiDAR, but way cheaper and way simpler and way more reliable. And we're seeing that those new sensors are coming into the market now and enables all kinds of new things you can do with sensing. And then I guess
I
one
mean,
other area that we care about is like resource mapping.
mhm.
Um, so like there's a lot of interest in like where's the water and what can we see on the surface of the moon. So, being able to sense that you can use radar, you can use a neutron or what's it called? There's a couple different sensors, but looking outside the visible spectrum to be able to see um, figure out what's actually there based on the different light that is bouncing off of it.
Okay. I feel like also in that context, I'm thinking about like, okay, the fact that there's one industry really supporting another here, and probably also vice versa. I think it's cool to kind of see that. The at the Space Grand Challenge, we focus on like hands-on technical problem solving. So students go into this game, and then
Yeah.
they have this capture the flag kind of
Hmm.
based version. They go in, and then they work with a group, a team, to really find all of these flags. When we are looking at all of these challenges, how important do you think the challenges are like this for preparing the next generation of mission operators and space engineers and people who are going to be working on the next lunar landers?
Oh, I mean, so we had a big plan about how the mission was going to go, and it totally did go that way in certain ways. But there's a bunch of things that didn't go right, and that's what you call an anomaly. So, and then there's an active investigation with a very short time component to resolve that anomaly. And so the skill, like you don't have time to figure out how to SSH into a computer or like what Linux commands to run. Like you're SSHing into test beds, running hardware in the loop tests on code. You're stepping into Linux debugging to like see where bottlenecks are. Um, Logging and being able to quickly find like the error in the log is super important. And then you're on the spacecraft now and you have to understand how all those Linux computers on the spacecraft, like our camera system is a Linux computer.
Mhm.
So being able to understand like, okay, what happens? What's the side effects of me running this SCP command from the flight computer to that? How's that going to affect the critical software that's keeping the thing in orbit, right? So
Mhm.
so Linux, SSH, file systems, super important. I think from a security perspective, the cloud is super awesome because like when we have large amounts of data, we want to be able to like horizontally scale that data processing so we get real-time response on the ground. But then you have to be very careful about security, right? That's kind of another area. So I don't know if I answer your question, but that's
Oh,
kind of
definitely. Well, that's funny that you kind of bring it up because there's probably, right, from we knew each other before this. I feel like there's probably a lot of tie over for you as well with Tractor Cloud, funny enough. So it's like
Oh
cool to kind
yeah.
of see you continuing to work on this. That's awesome.
Oh yeah. I mean, it's just like a big expensive tractor. It's in a remote area. It's got to work. People get mad if it doesn't.
Hmm. That's funny. It's a good analogy. I like it. And then the final question that we ask everybody that is here, what is one piece of advice that you would give the audience that's listening today?
You build your identity, your professional and personal identity incrementally. It's not something that you, at the end of your life, you know how it's going to go.
Hmm.
So, like, for me, I've always just found these opportunities immediately around me in my community that excited me, and just like got involved. Um, and that's given me a crazy journey that's way more fun and exciting than it would have been if I tried to plan it all out. And so I guess you think of that like you're collecting pieces of yourself as you go. And so it's just more like find some interesting stuff to collect. Don't worry so much about like how it's all going to work out.
I like that. I mean, that's even good advice for me. So, thank you for your time. I appreciate it.
Yeah, of course. Yeah. And if anyone is interested in learning more, they're welcome to reach out to me.
Well, thank you, Morgan. Appreciate it.